Hello class, and welcome to the physics portion of your LSIS class. So good morning, good afternoon, and good evening, depending on what time of day you decide to enjoy this asynchronous presentation. So in today's class we're going to be talking about Newtonian physics. And as the subtitle says, this is the foundation of all science as we know it. So we'll get into Newtonian physics, which has a lot to do with motion. And before we do that, we need to back up and learn a little bit about the history of science. So we'll take a little tour in the history of science. And we need to do this because our world is dominated by scientific thought. And whether you're aware of it or not, all of us think in scientific terms. We all have at least some understanding of what's been discovered through the scientific method. We have some understanding of the scientific method, even if we don't necessarily use it directly. And furthermore, our world is dominated now by technology. And this is obvious, but so much of the time we simply go ahead and use technology without thinking about the origin of the technology or the ramifications of the technology. In other words, what will the effect be of using this technology? For example, nuclear power. It's a very good thing in the sense that it provides a lot of power without making carbon dioxide, but it also can result in disaster, such as what happened in Fukushima and other power plant disasters such as Chernobyl. Also, we have a lot of other technogenic kind of problems in the world today. In other words, for example, the buildup of carbon dioxide in the atmosphere, the acidification of the ocean. All of these things are caused by a misuse or overuse of a technology. So technology is a double-edged sword. And it's good for us to think about these things. But on a deeper level, we've got to understand science itself, because it's so much part of our world, and therefore it's so much a part of us. Meaning that because we live in this world, for better or for worse, we think along scientific lines. That's our culture, and it's also our history. So when, especially as teachers, and you all are going to be teachers or already are teachers, and if you're a parent, you are a teacher. And the job of a teacher, one of the most important things we can do, is to help our students get to know themselves. And we also have to know ourselves, and when so much of who we are and how we think is formed by science and the history of science, it's our job to know something about it. So we have to learn a little bit about the history of science leading up to Isaac Newton, and then study directly what Newton's work was. But we can't just jump into what what his equations are and what his laws of motion are without understanding something about where he came from. Now we jump back to 300 BC, and this is the time of the ancient Greek philosophers. And two of the most famous of these philosophers are Plato and Aristotle. And this is a small section of a famous painting of Plato and Aristotle. And you see the two figures walking down this aisle, and as the title suggests, one is Plato and one is Aristotle. Now, both Plato and Aristotle are key to understanding science as we know it today. Now, back in the time of ancient Greece, there was no science. Natural phenomenon were understood as being the work of the gods, meaning you hear things such as, not necessarily in the Greek tradition, but in more other pagan traditions where, there would be a rain god and a lightning god and an ocean god, and these things existed in the Greek tradition as well. Well, all of these gods were needed to explain natural phenomenon because there was no scientific understanding. Now, Plato didn't believe in the Greek pantheon of gods as such. He was a believer, this is going to sound strange, but he worshipped numbers. Now, at first that seems crazy, worship a number. That doesn't make any sense. But upon a little bit of deeper inspection, what Plato was getting at was the fact that that numbers and mathematics represented something very, very real. Here's an example. Here's this example that if I draw a circle, for example, the circle on the left, it's obviously imperfect, and it doesn't hold to the rules of a circle, which are mathematical, and we'll get to that in a minute. But if I draw a circle with a compass, okay, it's getting better, and it's more of a perfect circle, but still, maybe I wobbled my hand a little bit as I was drawing it, or made some other mistake, and it didn't come out quite perfect. And then, of course, I could have a computer generate a circle, and computers unfortunately tend to blur this understanding in our minds because they are so perfect, but it's still not perfect. It's got pixels, squares along the edge, and if I zoom into the line has a width, and so it's not really a perfect circle. So you come quickly to the conclusion, and this was Plato's conclusion, that a perfect circle doesn't exist in the physical plane. Well, where does it exist? It exists in what Plato called the realm of the ideal, and this is the realm of mathematics. We know that a circle is defined as a shape that is equidistant from a center point. So every point on the circle is a given distance from the center, and so we know that that's what defines a circle as a circle. There are equations that define a circle. So, for example, the circumference of the circle is the number pi times the diameter. The area of the circle is pi r squared, so the radius squared times pi is the area of a circle. All of these numerical relationships are talking about an ideal circle, a circle that doesn't exist in nature or in anything that man can make. We can only make approximate circles. So for Plato, what was real was the ideal. What was real was the world of numerical relationships.